Hi everyone, and welcome to this video on surface area of cones. Now you can see from the pictures below we've got quite striking architectural designs of cones. I like the third one with the inverted bamboo cones. That's pretty cool. So it's in our interest to know a little bit about them if we're going to use them in design, for example. Now R, radius, pretty happy with that. H, perpendicular height, we've seen that for donkeys now, but the L, that's kind of something new to us. And what that L is referring to is this length here, and we call this the slanted length. Okay, and this apex is always directly above the center on a cone. If not, it's not a cone. Now, we need to understand the surface area, so I'm going to write total surface area. And that is equal to this curved surface area, which is actually the area of a sector. And, you know, we could work out the area of a sector, we're pretty good at that now. But we don't have the angles, we don't have anything. So what we actually did, we came up with a better formula for this, and it's just pi times r times L. And that's what this L is here, this slanted length. But we also have this flat area, which is the circle. So that is the formula for surface area. So we have a curved and we have a flat, just like we have on cylinders. So you are given this one in the exam, but you should know the area of a circle. So not too much to remember, we just have to put numbers in. Let's take a look. So this question, we have a cone, asked for find the surface area to 1 dp. I'll probably just leave it in terms of pi if I'm honest, because I'm sure all of you can hit a button on your calculator. And I don't have one today, so I'm not going to be able to do that. So always write the formula. So pi rl plus pi r squared. All good mathematicians write the formulas. Bad mathematicians don't. Okay, so don't fall in that trap. So pi times the radius, we've got that, times the slanted length, we've got that, easy peasy, plus pi times the radius squared. Okay, this is going to be a very simple question. So 8 fours are 32, so I have 32 pi. 16 pi, so add on 16 pi, 4 squared is 16. And just combine those because they are like terms. And we have 2d, because it's area. 2 dimensions being multiplied in the first term, 2 dimensions being multiplied in the second term, so it is definitely area. Alright, that was easier. So not often as easy as that one. For example, this is a little bit harder, a little bit more work. And the problem is, we don't have the radius. But the height that we have is perpendicular. So hopefully now you can see here we have a right angle triangle with 3 sides. Pythagoras' theorem. So if we use Pythagoras' theorem, we can work out this radius to be 5. I did that without any working because I can see that that is a Pythagorean triple. Like 3, 4, 5, you should know that one. 6, 8, 10 is just a multiple of that, often used, and the other one most commonly used is 5, 12, 13. So please learn your triples. Okay, so let's write the formula. We're good to go now. So they've just added another step, just working out either R or L using Pythagoras. It's pretty easy. So here's the formula. So we've got pi times 5 times 13 plus pi times 5 squared. 65 pi plus 25 pi is 90 pi centimeters squared. Pretty straightforward. Right, so the hardest type of question we can ask you to do is basically do it in reverse. So we've got the total surface area, which we didn't have before. That was the question, and we're going to be asked to find one of the unknowns, L or R. In this case, it's the slanted length, L. And you may be thinking, so I just use Pythagoras, but you can't use Pythagoras because you don't know the height. So we write the formula. This is where a lot of people go wrong. They just don't write the formulas, and they look at this and go, I don't know where to start. Okay, just write the formula and then plug things in. And at this point you may still not know, but once you start writing these in, because we have that, and we've got pi times 8 times x plus pi times 8 squared, you'll see, well, that's just a number, and the only thing we've got is one unknown. So this is solving a one-step equation, basically, with some funkier symbols. So let's tidy this up. So we've got 160 pi here, 8 pi's, so 8 times pi is 8 pi x plus 64 pi. Now, because it's an equation, if I divide both sides by pi, I have to do it to every single term on both sides. That's fine, I've just divided by a number, I can do that. I'll tidy this up, so I have 160 equals 8x plus 64. So let's get the x's on the right hand side on their own, let's minus the 64, divide by 8, and we have now worked out that the slanted length is indeed 12. Now, they could have made this question a bit harder. If they had not this as the question, but the height as the question, well, to do that, I would have had to work out the slanted length, in this case 12. So let's just add this on here. Right, what would the height be? Well, the height, if we think about it, let's just put an 8 there. So we've got h there, sorry, 8 and 12. We would just use Pythagoras' theorem. So 8 squared is 12 squared, take away 64. Oh, got a bit ahead of myself. 8 squared. So it's 144, take away 64, which is 80. So h is the square root of 80. What's that in surds? So that's, I'm just going to go like this. I can't see it. It's probably a 16 I haven't seen. Is it 16 fives? Doesn't matter. So that's root 4, root 2. So that's 2 root 2's, root 10. Oh, now I wish I had a calculator. So yeah, it was 16. 16 fives. Of course it's 16 times 5. Okay, so that's the height. So if they ask you the height, then you just have to find something else, and then that should allow you to then find the height. In this case, find the slanted length, use it with Pythagoras to find the height. Okay, that's it. Best of luck.